I will revisit this. This problem we have already seen, but we can revisit with the special concept now, how it works, and I'll take little lengthier problem as well. Then I'll take up the MATLAB. Okay. Now, view this problem. There are three buses, bus 1, bus 2, bus 3, and ground as a special reference. How these ground to bus 1, ground to bus 2, 1 to 2, 1 to 3, and 3 to 2 addition will create the Z bus for the system which is having three buses. A 3 cross 3 matrix can be framed. This was just visualized before discussing the Z bus problem. Now, how this work is outlined. So, in the previous discussion we did it. The discussion starts like this. There are three buses, bus 1, 2, 3, 3 dots. You can see 1, 2, 3, J as a reference. Totally 4 buses were marked. J as a reference, 1, 2, 3, 1, 2, 3. How connectivity from ground to 1, ground to 2, 1 to 2 is established by drawing the lines or segment is shown with these 4 identified bus dots. Reference to 1 like that. Let's see how it's being done. The first activity is reference to bus number 1. A line is interfaced. Okay. Then reference to bus number 2 is done. Correct. Then bus number 2 to 3 is established. You can just see the greenish element is the latest modification. The one which is taken first is the second. This is the third modification. Then connectivity between 2 and 1. And the last connectivity 1 and 3. You can see. This way, all these elements were interfaced in this particular problem. When we interface ground with the bus 1 is first time introduced with the system. It is type 1 modification. It is a branch modification type 1. Then Z bus will be of 1 cross 1. When I take bus 2 interface with the ground, 2 is introduced first time, but 2 is a new bus. Definitely 1 was old, 2 is new. The size of the Z bus will be 2 cross 2. Then when I introduce bus number 3 here, in this case, 2 to 3 I am adding. 2 to 3 when I am adding, it is a type 2 because 2 is old bus, 3 is new bus. 3 is new means it is a branch. It is a branch by type 2 modification. Therefore, this will definitely create a 3 cross 3 matrix in the system. Similarly, when I go to next modification of element, 2 to 1 when I add, you can see here, 2 is old, 1 is also old. Now, when I interface element between 2 old buses, one of the bus may be reference or not, but old, then it is a link. Then link by what type? Question comes. It is link by type 4 because 1 is also 1 and 2. If I consider they are not the reference buses. 1 is distinct, 2 is distinct, but 1 and 2 are old. This is type 4 modification of link I should use here. You can see here, output is 3 cross 3. Here also 3 cross 3. Tentatively 1 row and column extra that I have to dissolve. At the end, the resultant matrix will be 3 cross 3 only. Then the last activity which is done in this problem is connecting a line between 1 and 3. Now you can see 3 is already established in the previous work only. 3 is already the part of the work and 1 is also part of the work. Between 1 and 3 when I interface, definitely it is a link. Link of what type? Again type 4. Type 4 because 1 is old, 3 is old, like that. So this way you have to outline the work before we begin. Then our work starts systematically. That has been done here. When I introduce the first line, its self-impedance is mentioned here. Z1 is 0.15. It means 0.15 is a self-impedance. Then after interfacing this, Z bus dimension stand 1 cross 1, J 0.15. After having this. When I introduce next bus, 2 with the ground, you can see here what is being done. When I introduce 2 with the ground, no doubt, reference is involved, 2 is a new number, it is a branch by again type 1. When type 1 is there, dimension increases to 1 row, 1 column extra. That you can see here. Old bus was J.1. You just watch this number. Old Z bus was J.15. To this, one row at the bottom, one column at the right, one diagonal value get added. So the diagonally growth occurs here because I am connecting it from reference. The line or the row which is below the Z bus old, which is newly established row, will have a 0 entry, and reflection of that to the column side 0. Diagonal growth is ZB of this number Z2. What is the value of Z2? That is 0.075. So that 0.075 automatically rest back. You can see this is 0.075. I'll take you back. Z2 is what? 0.075. When I add reference to 2, this value become diagonal value in the modified Z bus. These two are 0 because you are starting from the reference. There is no link between 1 and 2 or 2 and 1 in this context. Hence, type 1 modification, whenever you follow, the diagonal growth occurs. Diagonal growth occurs. So this is witnessed when I take element number Z2 connected to bus 2 from reference. Size of the Z bus stood as 2 cross 2. Now this become a reference for you for the next modification. When I take next slide, you will see you are trying to add bus 2 to 3 element Z4. You can see Z4 is the element you are connecting from 2 to 3. Now what is this? We should see. Before this, what is your Z bus old? Z bus old is primitive value. The value was 2 cross 2. J.15, 0, 0, J.075. This is your old bus. When I connect bus 2 and 3 by another impedance line, 2 to 3 you are connecting. Then we know that one row appear extra in the matrix here. Then one column reflection of this as a transpose over here and a most diagonal value over here. Then you recall back what kind of modification is this? This is a branch, no doubt. 3 is first time introduced branch, but no one of them is connected to reference. It is type 2 modification. When type 2 modification comes, what is the logic? You have to draw the row, a column, where to where there is a connectivity. Row number 3 is copy paste of elements of row number connection from this point. It means 1, 2. 2 to 3 you are connecting. Elements of this second row are copy paste on the row number 3. That you can see over here. You can just watch this. 2 cross 2. This dimension you watch. This is old bus. Alright, J.15, 0. 0.75. This is your old. Like this you can imagine. This is your old bus. This is to be copy paste. Second row is copy paste. Correct? And you transpose this over here. 0, 0. Z2, Z2. And most diagonal value is what? Most diagonal value is where to where you are connecting? Bus 2 to bus 3. Then its diagonal Z22 plus ZB is a value. Z2 and Z22. What is this Z22? Here. 0.075 Z22 plus the value of incoming branch. Incoming branch is say 0.1. Definitely you will have 0.175 as the extreme element in this. After having interfaced this V2 to bus 2 to bus 3 as a type 2 modification, no doubt bus dimension increases to 3 cross 3 and third row is nothing but copy of the elements of second row and the diagonal element is JZ22 plus ZB, which is the new line I am connecting. There is no elimination because it is a branch. Now, when I move further, this is what the 2 to 3 when you do. The next process was what? Just I go back and tell you. After having this, what was the process? 2 to 1. What is 2 to 1 now? 2 is old, 1 is old. It is a link. Link of what type? Link of type number 4. It's because 2 is not the reference, 1 is not the reference. It is type 4. When type 4 comes, respective equation I must refer to modify the values of this. Similarly, 1 to 3, when I refer, 1 is not the reference, 3 is not the reference, that would again lead the final conclusion after the third step. After this, and similarly when I move, you can just see how we are going to add this. Clear? J.15, 0, 0.150, 0, 1.75. Can you see here? What is that extra row appear here? Extra column appear here as a link. Then you delete them. That's what you have to do. To do that, Z bus old I require. This is your Z bus old. Minus 1 divided by diagonal into a column into a row. Then what is this row? What is this column? If you want to see, you must see. Where to where you are connecting. Bus 2 to bus 1 you are connecting. Then differential of these two that you can see here. So the column what I would write here is J.15 minus 0. What is J.15? 1 minus 0. Row number 1 is pertaining to bus 1. Row number 2 is pertaining to bus 2. Elements of first row minus elements of second row are the result of this column here. J.15 minus 0. It is J.15 that you can see here. And second element 0 minus 0.075. It is minus J7.5. You can see here. Okay. And this element is 0 minus 0.075. It means the elements what would appear in the invisible row which is to be deleted. This is element over here is where to where there is a connectivity difference you should take. Bus number 1 minus bus number 2. Difference of these two. Z1 minus this value here. Like that. So same thing I am reflecting as a column. It become a column. That's what I wrote here. This is the column. The same thing when I write in the row, it become 0.15, 0.075 minus 0.075. This is a row, this is a column, and the diagonal. The diagonal is what? Z, JJ, Z, whatever the II, plus ZMN minus 2 times MN. So if I take this algebraic sum, that becomes the most diagonal element which I'll be using. If I replace it, it looks like this. A column, a row, the most diagonal, which is old, new, and 2 times this. For ZB, ZB plus ZJJ, ZKK minus 2 ZJK like that. If I take this, this is the value reflecting a term to be subtracted. This is a differential term to be subtracted from Z bus old. This bus value minus this value result me end of the work. This is the conclusion of adding a line between bus 1 and 2. That's called link modification type 4. The same thing is continued. If I continue this 1 to 3, what would happen now? 1 is not a new number. 3 is not a new number. Size of the Z bus remain 3 cross 3. But temporarily, one row, one column will be visualized for you. How is that? For that again, you just see this. So you will be having the particular representation. The Z bus old for this is this value. This is your Z bus old before this activity is interfaced. This is interconnected. What is the Z bus you have? This is the Z bus. Now, where to where you are connecting? You are connecting between 1 and 3. It is row number 1 element minus row number 3 element as the differential element. What I want to say here, row number 1 minus row number 3. This minus this is the value to be written here. This minus this is the value. It means row number 1 elements minus row number 3 elements are the additional elements appear as a link modification. Then same row I transpose here as a column and a diagonal at the end. The diagonal will be what? ZB plus Z new, Z old and 2 times this value. This formula. Then it is written here 0.0808 minus 0.0346 is the value here that you can see here. Then here. Can you see here? 0.0808 minus 0.036 as a difference, this one. Second row elements difference. Third column differences in the form of a row in the form of a column. It is ready. You can see here a column vector into same thing in the form of a row vector. Column, row, and diagonal 1 divided by this one. This is the product generating a difference matrix. This difference matrix is to be subtracted from the original matrix Z old 3 cross 3 matrix minus the addition of this result differential matrix, this one. Take subtraction of that result to final. This is the complete solution of your problem, like this way. So this way we can look into. Now before going to the next, I have one more interesting problem which I would like to share to you. Just a minute. I'll just take up this. This is a very large problem, which is very interesting problem. We'll see it. This will give a more clarity of what I am trying to convey you. Somebody can help me. This screen is visible to you? Somebody can reply me. This screen is visible?
Yes, sir.
Hello?
Yes, sir.
Just a minute. Can you see this problem? Very large problem. There are so many buses.
Yes, sir.
The circle number you can see. Bus number 1, bus number 2, bus number 3, bus number 4, and yellow colored elements are the segments of connectivity. Just observe this. How many transmission lines are there in this problem? Just see the yellow colored boxes. There are 7 transmission sections, 4 buses which are circled and square are lines, and there are J values given for each element. Form Z bus of this particular system by Z build algorithm is the outcome. By looking to this problem, how many buses are there? We must check. Basically 4 specific buses, ground as my special bus. Then what is my Z bus outcome? Size of the Z bus? It is 4 cross 4 at the end. Am I right? Then to build 4 cross 4 matrix, I should start from the scratch. How I should start? You just see the sequence what is mentioned. Bus number 1, you observe. Ground to bus number 1, J.1. It is titled as element number 1. That is the activity number 1 first being done. Then yellow box you can see 2. Interface ground to 2, J.1, activity number 2. Then yellow tag 3, you can just see 2 to 1, interfacing of this line, activity 3, activity 4, activity 5, activity 6, activity 7. This way, this work is outlined by the author. So now we will see how this activity will generate mathematical values in the form of a matrix. Just see how this activity 1 is being done. This is outlined this way. Let us start doing this from the reference. First, let us connect element to bus number 1. Next, ground to bus number 2. Next, 2 to 1. Next, 2 to 3. Correct? Next, 3 to 4. Next, 4 to 1. Next, 4 to 2 or 2 to 4, like this way. This is being outlined. This is a sketch of my path of work. While doing so, definitely I encounter all the types of modification. Type 1, 2, 3, 4. According to the type which I am encountering, I have to use the equation to connect that connectivity in the form of a matrix. Then say, let's say activity number 1. Ground to 1 when I connect. 1 is introduced first time. It is written green. The green says it is a branch. Dotted shows it is going to become a link by action. It is not that you have to follow the same pattern. You may change the direction and pattern. Those are links may become solid line. Those are solid may become link. But you are definite that certain definite number of paths will become dotted lines in the system. That is known by topology. Whatever is that, you have to begin in a very specific way. At least first must be a reference. So author has begun in this way. We'll just follow the track which is mentioned. Solid line 0 to 1, no doubt 1 is first time branch. Suppose if this is said 0 to 2. 2 is first time, it is a reference to 2, it is a type 1. Reference to 1, type 1. Reference to 2, type 2. Now activity number 3, between 1 and 2 when I connect, 1 is old, 2 is old, already addressed. It must be a link then. The link of what type? Then what type when I say, anyone is reference here? No, then it is type 4. Existing bus when I connect, it is type 4. This is a link by type 4. I should take the equation of that. Then activity number 4, 2 is old, 3 is first time. When 3 is first time, it is a branch. It is going to extend your Z bus by 1 cross 1 extra. It is a branch. Then 3 to 4. Definitely 4 is first time. Activity number 5 is a branch. Dimension of Z bus increases 1 row, 1 column extra. When 4 is reached, the activity number 6, 4 and 1. 4 is already the member of the system. 1 is already the member of system. The activity is actually the link. Again, link by what type? Type 4. No doubt, 1 is not the reference, 4 is not the reference. It is type 4 modification only. The same as 4 to 2, type 4 modification. This way, mathematically, I should take my view, what I am going to do. According to that, I have to take account of the work. Then let us begin this then. Let's see how a graphic is being mentioned. Connect 0 to 1 by j.1. Branch is added. Then node is first time addressed. Then what is the Z bus? You can see Z bus at the end of the activity is only 1 cross 1 matrix. The self impedance of that is mentioned, j.10. It is 1 cross 1. We know it. When I add reference to the new bus, it is just 1 cross 1 element. The self impedance of that is prevailing on the. Next, the second activity. Suppose ground to 2 is interfaced. Again, it is a type 1 modification because ground is involved, but 2 is new bus. Therefore, dimension of the Z bus now, what was original, to which 1 row, 1 column need to get added. But we'll see how that get added. See here. Old was j.10, 1 row extra, 1 column extra. Diagonal is specially addressed. As it is being addressed from the ground, nothing is connected. Then the diagonal growth is occurring. The diagonal growth is, diagonal most element is self impedance of the line you are connecting. The self impedance of the line is what? j.1. j.1 become the diagonal element, and these two values become automatically 0 because you are beginning from reference. Then the size of the bus has begun from 1 cross 1 to 2 cross 2 now. Because 1 is introduced, 2 is introduced, size must be 2 cross 2. Then, when the next activity is involved, now this become a primitive matrix for you. I am taking it. Now see what is being said. Between 2 and 1, they are decided to add a link. Because 2 is old, 1 is also old. Then size of the Z bus will not be crossing 2 cross 2. 2 cross 2 is the answer here. This is a 2 cross 2 answer. It will have a temporarily 1 row, 1 column, but they will get dissolved very soon. Ultimately, size will become 2 cross 2 only. That's what we will see here. Between 2 and 1, if you interface, how is that Z bus old get compelled? Just see here. Can you see here? This is the old matrix for you. Inner values. Yes. To which 1 row extra, 1 column extra. To remember this, there is a very simple logic. Just I'll minimize this and I'll show you in a single view. So, for this, what you should remember, where to where there is a connectivity. Just see here. This row element is, it is 2 and 1. You can see here. It is Z2L 21 minus 11. Second row minus first row difference. In some book, in the last class I was speaking, between 1 and 2 are connecting. Values of first row, values of second row. Difference you can mention. That's what is being done here. Here they mentioned 2 to 1 I am connecting. Then they made row number 2 data minus the row number 1 data is placed here. And row number 2 data minus the row number 1 data placed here. And these two were reflected as a column. Then diagonal is the extreme diagonal element we should see by the formula. So how it is being done? Just see here. Second row element which is 0, 0 minus j.1 minus 0.1. j.1 minus 0. plus j.1 and write them as a column here. Then what is this value? This value is j.4. How you got j.4? You just see the formula. What is ZLL? ZLL is, just you can see, Z11 plus Z22 minus 2 times Z12 and ZB. It means this is a type 4 modification. I am not doing anything new. Type 4 modification formula to get the diagonal element should be used. That is Z11 where connection started, Z22 where connection landed upon, minus 2 times the connectivity between 1 and 2 in the matrix, and the elemental impedance of the upcoming line which I am connecting. So how is this? Z11 j.1, Z22 j.1 minus j/Z12. What is this? This is the new term. Not there is no this is not visualized earlier. Now it is visualized. What is Z12? First row, second column. What is the value here? 0. 2 times of that one, 0. Plus the incoming element, which is j.2. If I add it, you can just see here, j.1 plus j.1, 0 plus j.2. Whole value become 0.4. That is the diagonal value I am getting. This is a tentative value. This is not the final value, because what I am doing is a link. Ultimately, this row and column will get removed. To get removed, I have to write first and I have to delete it later by modifying the original Z bus code here. To modify this, what I'll be doing? Modified value of 1 cross 1, modified value of 1 cross 2, modified value of 2 cross 1, modified value of 2. All these 4 cells I have to modify by taking old minus the end of this column and end of this row multiplication values divided by diagonal. That's what I'm going to do. Just see here. Old matrix. What is the old here? It's a dark color. Minus the column which is there into row which is there divided by diagonal. I'm doing in a matrix format at a time. This matrix old minus a column which is differential, a row which is differential divided by the extreme diagonal. This will make all the 4 cells at a time done. Manually, how I do it? J.10 minus this products minus J.10 into minus J.10 divided by J.4. Manually, I will do it. That is a modification for cell. For this cell, 0 minus end of this column J.10 into end of its row minus J.10 divided by diagonal. This I have to do it. That will become modification of this. Then modification of this is what? 0 minus product of J minus 0.10 end of second row. What is there here? J.10 divided by diagonal value. And what about this value? J.10 minus J.10 into J.10 divided by J.4. All were mentioned in the form of a matrix directly. 1, 1, 1, 2, 2, 2, like this way. So when I do it, naturally this row and this column get deleted. All these 4 cells values become automatically modified. That you can see here. After modification of this, J.1, 0, 0, J.1 with the deletion of this now become J.075, J.025, J.025, J.07. Nothing but you have to delete this, means you have to flash this data on this with the relation. Then automatically these 4 cells get modified. This is about adding this particular link, activity number 3. Then what is activity number 4 for me? You can just see here. Activity 4 is connecting a line between 2 and 3. That is there. Can you see? So 1, 2, 3. 2 to 3. This is 3 is first time addressed. This must be a branch. Branch by what type? Type number 1. Because 1 or 2. Somebody help me. When I connect element between 2 to 3, is it a branch modification by type 1 or type 2? Somebody help me. Is it type 1 or type 2? Are you there? Are you there? Somebody can
No,
reply.
sir.
Yeah. Is it type 1 or type 2? Somebody can reply. When I modify the network by adding a branch, will it become a type 1 modification or type 2 modification? Because
Two, sir.
yeah, perfectly right. It is type 2 modification because you are adding a branch, new bus 3 is introduced. No one of them, 3 is not the reference, 2 is not the reference. It is type 2 modification. Therefore, whatever the 2 cross 2 matrix you had here, now we'll have one row extra, one column extra as a standard when I complete this activity. To do that, what I will do? Partial network should be considered. So partial network is written in this part. Am I right? This is partial network, to which one row extra, one column extra appears. Then what are the values of these things? Very simple. Type 2 modification you need to remember. For that, it's very simple to remember. When you are adding a line between 2 to 3, I said very clearly, copy the elements of row number 2 and place them on the element number, respective elements of row number 3. It means row number 2, cut or copy, paste here. That you can see here. Has it been done? Row number 2, J.025, J.075. These values are copy paste here. Can you see in the right side here? 2 to 3 were adding. Row number 2, copy paste. Copy paste. Then these two elements you reflect as a transpose here. 3 1 1 3, 3 2 2 3, and this diagonal is to be considered. For this equation is there. Where to where we are connecting? Bus 2 to bus 3 we are connecting. Then Z22 plus ZB. You can see here. Z22 plus incoming line. That is, incoming line is J.3. J.3 and Z22 was 0.075. It becomes 0.375. Can you see here? 0.3 is the incoming line. 0.075 is the Z22. So Z22 plus ZB is the value. Once I complete this addition, it's going to result me a 3 cross 3 matrix for me. So this now becomes the dimension of the Z bus once I complete this activity of adding an element number 4. Now, no need to delete it because it is a branch. Now further, when I want to go ahead, when I add an element here, you can see here 3 to 4. This element. 4 is again a new bus. 3 is old bus. No one of them is a reference. Then it is again type 2 branch. Branch modification by type 2. No doubt here also one row, one column extra appears. Again the logic is same. Row number 4 elements are nothing but row number 3 copy paste. Copy the row number 3 elements to row number 4. Let's see, is it being done or not? This is our old bus 3 cross 3 which you have seen here. This is the same old bus. Same thing you will see here. Correct? Then one row extra written here to be computed, one column. Then row number 3 copy paste on row number 4. You can see here, red line you can see J.025, J.075, J.375, copy paste. And this row you reflect as a column here, transpose of that. And the diagonal, what this diagonal is? The diagonal says where to where you are connecting. 3 to 4 you are connecting. Then Z33. What is Z33? 0.375. 0.375 Z33 plus incoming line data. What is incoming line data? J.15. It is 0.375 plus 0.15. If I add these two, that will result me 0.525. So therefore, you will get one row, one column, one diagonal extra. When I add a branch, now it became 4 cross 4 for me. Now, all the 4 buses have been addressed, 4 cross 4 matrix is seen. Now, the activity remaining is either to add 4 to 1 and 4 to 2. Those two are definitely linked because 1, 2, 3, 4 are all the old numbers to me. Anything which I connect to them is a link itself. Therefore, let us see how an activity of connecting 4 to 1 become link for me. So 4 to 1 is J.25, a link. How that link is getting established. You can see this is the old bus 4 cross 4. 4 cross 4. Clear? Then one row extra. Same thing I reflect as a column here, and one diagonal I should get. This is type number 3 or 4 here. Somebody help me. Link. Is it a type 3 or type 4 which I am adding here? 1 is not the reference, 4 is not the reference. Then it must be type number 4. So type 4 modification I should refer here. Now there is again logic. Where to where you are connecting it between 4 and 1. So you can use difference of the row number 1 and row number 4 or 4 or 1 depending upon the logic. You can just see here, just observe here what is being done here. Z L1 Z12 Z41 minus Z11 Z42 minus Z12 Z43 minus Z13 Z244 minus 14. What is being done? Row number 4 minus row number 1 data. You can see 0.025 minus 0.075 I should write here in this position. Here 0.075 minus 0.025 I should write here. Like this, whichever the row which I am connecting, whichever the bus and whichever the old bus I am connecting, difference of those impedances column wise I should extend here. So fourth row first column element minus first row first column. So is it first or not? So you can see here. Fourth bus, first bus. Difference of these two column wise I should write. So the same thing is written here. You can just see. I just mentioned J.025 minus 0.075. Definitely negative answer comes here because J.075 is larger than J.025. No matter, plus or minus. Fourth row elements minus first row element. Difference I should write. Difference of this, this difference, this difference. You can see. So I will generate 4 elements here. These 4 elements I rewrite over here as a column. Correct? Then the diagonal. Diagonal we know. What was the diagonal? Diagonal is where to where I am connecting. I am connecting it from bus number 1 and 4. Then I have a rule ZB incoming line data plus Z11 plus Z44 minus 2 times Z14 is the formula. That formula give me the diagonal element of which. Then accordingly I will be creating J point. Let me see how it is written. You can see Z11 plus Z44 minus 2 times Z14 plus incoming ZB. If I add all these, that will reflect me J.8. That is my diagonal value. But this is temporarily created row and column, which is for the link, which has to be deleted. I don't want to see them. But when I delete them, all these 4 cross 4, 16 elements, you have to revise. All these 4 cross 4 matrix elements, you have to refresh and rewrite. How to do it? For that, in a computer, how we do? Old Z bus, which is inside this, before the addition of new row, new column, minus a column which is here into row which is here, divided by diagonal. That you can see here. Old Z bus, which is inside 4 cross 4, is 4 cross 4 minus the column 1, 2, 3, 4, these values into these 1, 2, 3, 4 up to the diagonal. You have to leave the diagonal. Leaving the diagonal, what is the up? This is the column. Leaving the diagonal, remaining is the row here. So product of this divided by diagonal element. This is going to create 4 cross 4 matrix. 4 cross 4 matrix, and old 4 cross 4 minus this value is the actual correction for these cells. Then these automatically get deleted. You can see here. Your rewind. Now you got, by adding this element, 4 cross 4 matrix, original 4 cross 4 matrix now got modified little. Similarly, when I add 4 to 2, a line between 4 and 2, which is the last activity here that you can see. 4 to 2. It is a link again. Again, 2 is not a reference, 4 is not a reference. So this link will definitely create one row extra, one column extra temporarily, and you have to dissolve it and you have to take out. For that, again, what you will do? So revise the 4 cross 4. Then you can see 4 and 2. Row number 4 minus row number 2 data. This fourth row element, first, second row element, difference of this we should write. This is the logic you have to understand. Once you numerically see these things, writing this problem is mechanical first, then understanding is quite comfortable. Row number 4 minus row number 2 difference. Row number 4, row number 2. You have to shift. Row number 4, row number 2 difference. Where to where you connect? 4 to 2. 4 minus 2, 4 minus 2, 4 minus 2. Column wise you have to move. Earlier I did 4 minus 1, 4 minus 1 because I am connecting from 4 to 1. This time it is 4 to 2. Then the diagonal as usual. What is the diagonal? Z44 plus Z22 minus 2 times Z24 plus ZB. That is the value of diagonal here. This row you transpose as a column here. This is a column useful. This is a row useful. This is a Z diagonal useful for your updation of this 4 cross 4 matrix. You can see here. Once I get the values, these are the values. This column and row I have to delete it. Once I want to delete, I should go for this. Old minus column vector, row vector divided by diagonal. That will reflect me final answer. This won't be the problem of your exam, no doubt. This is to give you the strength, how the logic functions. Okay. This way, this material I am going to share you can just go through how you can get into that. Okay. So this is how I wanted to show you. And now I'll move to MATLAB section where the particular program which we have run has already seen on the MATLAB. I'll just show you just a minute. Okay. You can just see this my MATLAB window. Hope my MATLAB window is visible to you all. Somebody help me. Is my MATLAB window is visible to you all? Yes. Somebody help me. Yeah, yeah, nice. Okay, I'll just. Okay. So here, what is being done? CLC, clear command line. Clear all the variable in the command window and space. Then Z is the input matrix for you. This problem I have taken from your hand calculation part. What is that hand calculation? Then I will show you that particular hand calculation which I am taken is from your PSAS folder. Just I'll open up that PSAS folder. You will be able to see that. Hope you are able to see my screen, which I am opening up. Okay. I'm just scrolling. That good algorithm, I'll just move and stop there. I'll just take the problem. Don't worry about the problem value, worry about the requirement. Okay. It was on page number 9, I guess. This is the problem. Right? So, construct Z bus for the given power system having reference bus number 1, bus number 2, bus number 3 with the relevant data J.25, a line between reference and 1, J.25 line between reference and 2, between 1 and 2 J.1, 1 and 3 J.1, 2 and 3 J.1, like that. That data on the problem is given to us. That is titled as a table. Element number. How many are there? 5 elements are there. 1, 2, 3, 4, 5. How they are connected from P to Q? PQ says bus code. 1 to reference 0 J.25 this one. 2 to 1 2 to 1 or 1 to 2 J.1. Like that, connectivity is mentioned in the table. So this table is the input to me. Such a table which is given to me, I can draw a network of that. I can analyze how I should proceed here. I should begin connecting lines one by one. At least my first beginning should be from the reference. I can start 0 to 1 as my first activity, then 1 to 2 second activity, then 1 to 3 next activity, then 2 to 0 4, then 2 to 3 I can outline my work. Accordingly, some of the activity become type 1, type 2, type 3, type 4 according to the sequence of their interconnection. According to their sequence of interconnection and mechanism, the respective equations must be adopted in programming. Then this table give me an insight. Now you can tell me 1 to 0. 1 is first time, 0 is reference. It must be type 1. Is 0 to 1, type 1. When I connect this line 2 to 1, 1 is old, 2 is new. 1 is not a reference, 2 is not a, this must be type number 2 connectivity. Likewise, I will create in the program what kind of connectivity is this, like that. So that I am trying to convey you. So how I am doing it? In this I have written here 1 to 0, 0.25, type is 1. 1 to 2, it is J.1, type number 2. Then 2 to 0, 2 to 0 is now 2 is old, 0 is my reference. So old bus, reference bus, it is type 3, link I created. Then 3 to 1, 3 is first time, 1 is old, no one is reference, branch modification 2. And between 3 and 2, it is 3 is not the reference, 2 is not the reference, but 2 and 3 are old buses. It is called a link of type 4. What I did, I made this arrangement. All the types will come here. Type 1, type 2, type 3, type 4 will appear in this problem. Like that, I arrange the problem here. Given the problem, which is over here, this problem is given to me. This is arranged over here in this way. Then that is my input matrix, Z equal to input matrix. I will start reading these things. Read this, which is the bus 1, where it is connecting 0. Then what is the value? 0.25. What type of connectivity is this? Type 1. Then my program will automatically understand I should use type 1 equation for this value, type 2 for this, type 3 for this, again type 2 for this, type 4 for this. Like that, I will retreat that data into my program. So this matrix is input from the problem table. Then I have done a code. So I want to create a Z. What is the size of this matrix? I don't know. When I call a command, size of Z, it will give me how many rows are there, how many columns are there. So I'll be calling to know how many rows, how many columns are there, size of M. Then I initialize it, get the value. So Z from 1 to 5. 1 to 5 rows are there. 1, 2, 3, 4, 5 columns are there. It is a 5 cross 5 matrix as for me here. So M if I call as a number of rows, N if I call a number of columns, M is also 5, N is also 5. So therefore I can say, so I can call Z of second value is a from bus, third value destination bus, fourth value with what value, and the fifth value by what type, I will come to know. So this I have to treat automatically. When I position Z of 1, 2, it is from bus. Z of 1, 3 means where it is connected. Z of 1, 4 means what is the line data. Z of 1, 5 means what type of connection. So this I will make a cyclic by operating a loop. For that I require operator. Hence I can say for k equal to 1 to M, M being number of rows. I just check from bus FB equal to check from k comma this one. Let me make it maximize. I will just undock it. It will be very much clear for you. Clear? I just make it clear for you. So k comma a equal to FB from bus equal to Z of k comma 2. 2 bus TB. 2 bus is k comma 3. What is k comma 3? It is k is the operator. What is the row here? Here 2 is the column number. 3 is the column number. Z is the variable of whose, I can say Z of k comma 2. When k is 1, it is pointing to first row. K is 2 pointing to second row. K is 3 pointing to third row, fourth row, fifth row, like that. K is incrementing from 1 to 5, and definitely I need from bus to bus data and type. Only these are required. Elements are not required because I know the elements there are 5. Therefore, from bus FB is Z of K comma 2, to bus Z of K comma 3. Value is the fourth position K comma 4. Then type equal to K comma 5. From this I will check what is the smallest number I wrote here. New bus from these two. What is the new bus? New is maximum of these two. Maximum of these two is 1. I call it as max of FB TB. FB is the number. What is the number here? 1. What is the number here? 0. Max of this is 1 in this case. So max number I consider as a new bus. Min of these two, minimum of these two is 0. That I consider smallest as reference. Connect from small bus number to large bus number is the logic here. So new bus I check as a max of from bus to bus. Reference bus I check as minimum of from bus to bus. Then once I do it, I check which type of logic is this. Type 1, type 2, type. You can see here. Switch by type. Type is having the value K comma 5. K comma 5 is 1 means type 1. Second row, it is 2, type 2, type 3. It is definite. You have already viewed the problem. You configured it 1, 2, 3, 4 here. Automatically your program will take care of that equation here. Then if type is value 1, it will come and assemble here. Z bus, what is the value here? Suppose you are in the first row, 1 comma 0. New bus is 1, 1 comma 1. Z bus 1 comma 1 is Z bus, new bus comma new, 1 comma 1 equal to value. Value is only 0.25. 1 cross 1 value appeared here. Suppose second row, it appears second row, 1 comma 2. What is the max number? 2. What is the min number? 2. Min number is 1, max number is 2. It is 2 cross 2. Then value of this is old bus minus 2 cross 2. It is going to add here. So display type 2 and Z bus equal to add Z bus into it. If I run it, you will be seeing. Let me run it first. Let me run it. If I run it, you will be seeing it as an answer. You can see this. When I run this, you will see the details. What is Z bus in the problem which I entered? 1 to 0, 1 to 2, 2 to 0, 3 to 1, 3 to 2, whatever value entered. It check. What is the from bus first? 1 and 0. From bus is 1. 2 bus is smallest of this. Okay. Value is 0.25. Okay. Type is 1. Checks automatically. Your first value Z bus is only 0.25. Output is 0.25. Then K automatically becomes second. Automatically second row. Second row it enters. The value become, just see here, 2 cross 2 matrix. It was only 0.25 next earlier. Now this copy paste 0.25 plus 0.1 automatically diagonal growth occurs here. Now the output is 2 cross 2. When next line is added, okay, automatically it's a link. Okay, it modifies the values. Same 2 cross 2 value, whatever you had here, these values are modified. This is type 3. What is type 3? Type 3 is a link. Link will not increase the rows and column. It will modify the cell values. So cell value will be requiring a column, a row, multiply, a diagonal. Then you take the decision. This is your 2 cross 2 matrix. When you add a next line, okay, again that is type 2. Type 2 is nothing but building 1 row, 1 column extra. So to this 1 row extra, 1 column extra. It is a copy paste of 1 to 3. It is a 1 to 3 addition. First row is copy paste like this. You reflect this. This is the value of 1428 and its value. So it is addition. Like this, Z bus builds automatically. Last one. Here. This is final. It means whatever I am speaking, this is just a program. This program automatically makes the things. So suppose if I want to run this program, which is another modification, here you can see the same program, same problem. I made my arrangement type 1, type 2, type 3, type 2, type 4 by rearranging the cells. All the 4 types I have seen. You can see the green color, same problem. Row number 3, I shifted upward. Okay, then types become different. Types become 1, 1, 2, 4, 4. Type 3 is eliminated here. Your work may not include all the types, but still it works. So I can show this. I can eliminate this control tabs. Then I mask this. The same problem. Control R. Okay. If the same problem, I hidden this. I don't want to run this. I want to run this by shifting second row to the upper. Automatically, first line is type 1. Second line is type 1. Third line is type 2, type 4, type 3 has not come. Let's see whether it gives the same answer or not. Now I have run this in the MATLAB. Let me see the answers. You can just see the same answer comes here. Okay, I'll clear it once again. Control C, PLC, clear. I have cleared the command. I go to the particular program. Okay, I just make one layout also comfortable to you, so that you can see the same outlook here. I just make editor, run. Then I'll come back. I just see same answer. It doesn't change anything. Problem. First row, 0.25. See here, 0, 0 have come here. You can see when first activity is type 1, 0 to 0.25, bus 0 to bus 1, bus 0 to bus 2, 0, 0, 0.25, diagonally growth occur. This was not seen in the old logic. Old bus was different. Then I added bus 3. You can see here 0, 0, 0, something different in the work. But still then my logics are running very perfect. But I have begun from reference. Then bus 3 is added, 3 cross 3. Then next line, a link, 3 cross 3 modification. Next, again type 4 modification, 3 cross 3, automatically comes. It doesn't mean that I have to do this way or that way only. What matters is what is the way you configure your work. That matters to complete your task. In that way, you can see carefully and you can do it. This is already a proven program which definitely works. You can just run on your MATLAB windows and you can see the answers matching for both. When you run one, how is that? When you run this same problem with a different, how it runs, you can see. So with this, I can say this program you can run very systematically because it's arranged. Case 1 is type 1 equation. Case 2 means type 2 equation. I have written the equation 1, 2, 3, 4. Type 1 equation 2, 3 in the respective blocks here. Those blocks will automatically get access whenever type become 1 will jump to block 1. Type become 2 will jump to block 2 and end up. In that way, this entire work is in the loop. Whole work. This work is in the loop. For how many times? All the lines are traced. Till all the lines are traced, this is put in the loop. You can see the for loop begin here. This is the beginning of for loop. See the end here. End is at the extreme end here. This for loop begins here. So many conditions and ends here. So all the lines it will trace. Then it is going to give me final conclusion as my output matrix. This way, this program can be run on your computers very easily